Hey guys, I'm about to get started on the first of a trio of Admiral sets that all have basically the same chassis. This is a 21B1 chassis, and I think I have another 21B1 and I think a 21D1, all very similar. This is the tabletop bakelite set. I did a video a while back when I talked about all three when they were out on my back porch. So this is the first one I'm going to work on. This is the one that has the RCA Solvarama picture tube, and I can now see it's a 17B p4B. This test's really strong. It's aluminized, so I expect it'll be a really nice bright picture. I've got my big old box of parts. Should be all the parts I need for all three sets. So first thing I want to do with this set is power it up with the rectifier tube pulled out, the p1o4. I want to make sure that the transformer is good. So with this out of the circuit, there won't be any high voltage going to the tubes. It'll just be filament juice, so all the tubes should light up. Assuming that happens, I then want to check the critical components. So I've got my schematic here, and it's got resistance. So for example, we've got vertical deflection yoke, vertical output transformer, flyback, and so on, and the yoke. They have resistance readings for all those coils. I want to make sure they're all good. Finding replacements can be kind of tough. So I just pulled out the rectifier, cheater cord. Oh, by the way, I did fix my Variac. It's been out of commission for a while. The problem was not what I expected it to be. It's actually the stupid little cheapo voltmeter that goes directly across the output pins. It's completely fried, dead short, so I kept blowing fuses. So now I don't have any meter on here, but the dial is fairly accurate, and I can always stick an AC voltmeter on there. Not that I really need a Variac for this, because I'm just going to put it on full juice to begin. Not that I really need a Variac for this test, because I'm going to be putting it on full juice. But it does have a fuse in it, unlike this set, so that'll give me some protection. Alright, I've got my multimeter stuck in here to pins 4 and 6 on the p1o4, which on the schematic there, they show it should be about 310 volts AC. See what's this meter good up to. This is 750, so should be alright. And Variac on. And here we go. I really hate this part. You never know what might happen. Alright. Tubes are lighting up. Got 450 volts or so AC. A little more than I was expecting, but then again, there's no load on it, so it's probably alright. Alright, cool. All the tubes are happily glowing. So, now I will move on to checking the resistances. I imagine I'll have to unsolder some wires here and there to get things out of the circuit so I can accurately check the resistance. I don't need to worry about discharging the electrolytics or anything, because with that rectifier tube out, nothing really got any voltage, nothing charged up. Alright, high voltage cage makes a real nice stable surface. So I can easily work on a set on its side, just like this. Oh yeah, this is the set with all those German resistors. Another set, the other chassis, the Bakelite console version, they were all Japanese resistors. I used to think that all these Admirals were made in Chicago, but now it turns out they had several factories around the country, so I imagine one had the Japanese and one had the German resistors. There was such a boom in the early 50s and the Korean War was going on, so I think they might have had some difficulty in sourcing parts. Alright, so there's one transformer, another one, there's another one. I'll check those three. One of those is a vertical output transformer, one should be the vertical oscillator. So there's the oscillator, and there's the output transformer. I'm not sure what the other one is. Part of the horizontal circuit. First up, I'm checking the vertical output transformer. It's got 3 wires, blue, yellow, and red. Now, this is the one that really concerned me when I first looked at this chassis because it's a replacement. There should be 13 ohms on one side of the tap and 1300 on the other side of the tap. Now here's the 13 ohm side, which is pretty much dead on. The other side, though, it's about 1,000 ohms, not 1,300. Hopefully that won't be a problem. I can't tell if this is an exact replacement or not. I don't see a number on it or anything. Alright, next up, this little guy here. It's the vertical oscillator transformer. Between red and blue, we should have 160 ohms. 156.5, close enough. And yellow and green, it should be 950. So let's see. Here's the yellow. 912. So loosen it. And the third one, I wasn't sure about this guy down here. I bet that's the audio output transformer. This is 6V6, which is that guy down there. Oh, they don't show the resistance reading on that transformer. Well, I'll just assume it's good. We'll find out if we have any sound or not later on. Alright, so let's move on to the flyback. That's really the most critical thing. It's got 1, 2, 3, 4, 5 sections on here. They show resistance for most of them, all except for the one going to the filament on the 1B3. But the other sections are good. It's probably a safe bet that that's good. And quite frankly, that's usually just one loop of wire on a transformer iron frame, so not a problem. Now, it's down here. I think I'll try flipping the chassis down and take the cover off the high voltage cage. Let's see if we can do it from the top. Screws that there. Let's get this cute little spring-loaded trapdoor down there. I think I'll just take this whole thing off. Really get down in there. It's a little bit different than what I'm used to. Usually this tube is inside of this horizontal output tube. In this case, all that's inside here is just the flyback and the rectifier. I checked every section on the flyback, and I'm happy to say it passed with flying colors. One thing I wasn't too happy to see though is the fuse, 14 amp fuse. It's supposed to be 0.25 amps, a quarter of an amp. So it was offering no protection whatsoever. Might as well just put a piece of wire across that. So of course I'll be putting in the proper amperage fuse. Alright, that leaves focus coil and yoke. While I've got this opened up, I'll clean it out too because it's pretty darn dusty. High voltage tends to really attract a lot of dust, so this is really nasty down here. Otherwise, this stuff's really clean. The tubes are really clean too. I mean, I don't know where this was stored, but good shape. Compressed air, really handy stuff to have. All right, that's better. Alright, everything checks out. The horizontal windings on the yoke, the vertical windings on the yoke, the focus magnet, and focus control. So, full steam ahead. I'm going to start recapping. In particular, I am going to bypass the 3 can electrolytics and do this horizontal area first. This stuff is usually the most problematic, the horizontal and the high voltage circuitry, and I can already see that, for example, this power resistor looks really fried. So, I've got all my parts right here. So, time to sort through those and start replacing these capacitors. I discovered there are several what they call couplates in this set. A little one up here, and one here, and a big one down here. However, those are nowhere to be found on the schematic that I've been going off of. Well, it turns out that, like so many other early Admiral sets, there were many revisions of this chassis. Eventually, I found it in a 1952 copy of Most Often Needed Servicing Info from Beatman. And I think this is the very last revision of this chassis. And here we go. So there's the large one. That's one that really threw me off. So if you look on the schematic here, it has 6AV6. Feeding a 6V6 and a bunch of discrete components, none of which are in my set. So it turns out they replaced that with this very different looking circuit here. So what's inside the dashed line is the couplate. So there are 3 resistors and 1 capacitor, and 4 leads coming out of it, it looks like. So sometimes these can be a bit tricky to test because you don't have access to all the internal components. But I think in this case, if I can check that 47K going from this lead to this lead, and I can check the 1 meg between 2 and 4, and I can check the 150K from 3 to 1. And if I got a capacitor tester on 1 to 2, I could check the 0.01. And if they are bad, I could build this up from discrete components. The reason they would use these was for better stability. I'm not used to seeing one in the audio circuit like this though. What I am used to seeing is this guy over here, which is the vertical integrator. It's fairly important that these be matched well, and it's not that unusual for a 1950-51 set and later to use these hybrid modules for the integrator. And the third one, a little small one up here, I'm not entirely sure what that one's for. Oh, here it is. This guy, it's just 2 resistors and 1 capacitor. And that's on the video amp. Looks like on the output might be part of the AGC bus. I can also check that one easily enough. Moving on. No, that's only got 2 leads, so I don't have internal access to the midpoint of those 2 resistors. I can check the overall resistance between 1 and 2, but not the 2 individual sections. Likewise on the integrator, you only get 3 pins, so I have no idea. I can't check the 22K, the 8200 or 8200. Now, on the good side, I don't think I've ever encountered any of these that were bad enough that the set wouldn't function. So, for the time being, I'll assume that these are okay. And if there are problems in any of these circuits, then I'll check them in more detail. There's the new 7.5K power resistor installed in parallel with the old original 3K cam dome resistor, which tests okay, so I'll leave it in there for now. We'll see how it holds up. I then moved on to recapping more of the set, and I started encountering more and more differences between what I saw and what was on the schematic I was working off of. So I went back looking through my service manuals, and I think I finally have the right schematic. So here's what I was working off of originally, which is what I found in Riders Volume 6 for the 21B1 chassis. This I quickly found out did not match what I had, because this does not have any couplates in it, and I have 3 in this set. And quite a few other differences. So I had then moved on to one from a Wallace Telliade compendium, and I was going off of chassis 21B1 runs 1 through 10, which does have the couplates, but it does not have that 7.5K power resistor in parallel with the 3K, so I knew that wasn't quite right. I then found what I showed you a moment ago with just some service notes, and I thought between those notes and the schematic I'd be good to go. But then I noticed something. For the video detector here, it's got a 6AL5 dual diode tube. This does not have a 6AL5. What it's got is an actual semiconductor diode right there. That is the detector diode. So I went looking some more, and I found this, which is chassis 21B1 runs 11 through 14 and runs 14 through 26. So they made at least 26 variations of this set. I flipped back and forth between these two, and they both have that parallel power resistor and the detector diode. So I was having some trouble figuring out what the heck is the difference between the two, and then I noticed the RF amp. This says 6AG5, 6BC5, or 6CB6. This set does have a 6AG5. If you look at runs on this side, it's got a 6BQ7 or 6BK7. So good to go on this. Now this does cover runs 11, 12, 13, 14. So I'm not sure what the subtle differences are between those 4 variations covered in the schematic, but this is the closest I've been able to find. So I put this up on my scanner and made some photocopies so I can get a highlighter and start marking things off as I check them. I just removed and gutted the main filter electrolytic capacitor so I can restuff it, and now I'm working on another one. I'll zoom in a bit so try to give you some idea what that involves. So this is it down here. We've got 3 lugs for the 3 electrolytic sections, and then some twist locks around the outside. I've used my solder sucker and removed solder from the main lugs here, and now I'm carefully teasing away the component leads so I can kind of unravel them without damaging anything. So here's this capacitor lead and this little wire. It's still a bit loose, or still a bit stuck on there, so heat it up a little bit. You want to use a solder sucker and some solder wick. There's usually a little bit left behind. Just put that out. And so on. I got 2 more red wires down here to get out. Okay, I got the wires and component leads off the 3 lugs. That was a relatively easy part. Now I need to untwist the twist lock tabs. One of them was never soldered, so all I had to do was take these flat-jawed, small needle nose pliers here and get it flush with the slot cut in the chassis. You really want to use something with flat jaws like this instead of something like this with serrated jaws. If you use serrated jaws and grab onto these and start twisting around, they're going to chew them up and maybe weaken them to the point where they break off. And I really don't want to do that, because after I rebuild this capacitor, I want to remount it and twist these back over to hold it in place. So that got that one. Now these other 2 have quite a bit of solder on them, and I need to get that cleared away so I can untwist them. Because they're soldered to the chassis, you can't just use a dinky old pencil iron like this. This chassis acts as a giant heat sink, and it'll just immediately cool off the tip, and I won't be able to melt the solder. So what I've been using, with some success, is a Weller 260 watt gun. It's just powerful enough to melt away the solder. Now it may seem like 260 watts should be more than enough, but there's really not a whole lot of thermal mass on this tip. So what I do is I pull the trigger while not touching anything and let it heat up for a minute or 2, and then touch it to it, and that's usually enough to get a little bit melted. I'll pull up some solder wick to it and slowly start getting that solder out of there. These guns are meant for intermittent operation, so I don't want to leave this pulled too long, but I have to do it long enough so I can build up a decent amount of heat to start melting this out. I don't know, get some going there. See what happens? As soon as I start to pull the gun away, then the solder immediately hardened and the solder wick is now fused to the chassis. What I'd really like to get is one of the vintage soldering irons. Well, actually, I do have a couple. I got it at an estate sale. An American Beauty 100 watt iron. I've tried using it, and it's still it's even worse than this. Even at 100 watts and with a big fat tip, it's just not quite enough. I've also got a 260 or 225 vintage big old iron, but the continuity seems to be open, so I think it's burned out. So for the time being, This is the best I got. Eventually I'll get there. Once I do eat away all that solder, use the same pliers, untwist it, and then start wiggling it from the other side. It should come out. I finished removing the last of the capacitors, and in case any of you were wondering whether these capacitors are good or bad, I've hooked it up to a capacitor tester. This particular section should be 80 microfarad at 350 volts. I've got my tester hooked up to check for leakage at 300 volts, and that light should not be on. I've had this hooked up for about 5 minutes and that light is still on. The light should go out in just a second or two. I've also checked the other two sections and they are leaky as well, so this capacitor is definitely bad. I've pried open the end of both of these electrolytics and removed the metal ring. And now I want to get the insides out just like I did on this other one. What's inside these cans is a jelly roll of aluminum foil and a paper-like material that's soaked with the electrolyte. It's held in by this glob of tar at the end. So to get these insides out, I need to heat that tar up. I use a heat gun for that. Got a Wagner. I'm not sure what the wattage is. Let's see. I think it's a 1000 watt heat gun. I use it on high. Let the heat do its work. It will take a while for the heat to get through this aluminum and heat up the end and make that tar gooey. Once you do, the insides slide out fairly easily. If you start tugging on this end and the tar hasn't fully loosened up yet, it's very easy to damage these lugs. So I will get this going. What I do is I loosely hold two of the lugs in the plier jaws and start heating. These cans do have safety plugs on them, like here, so I've never had one actually vent any type of material or the insides pop out or anything like that. Even so, I always point this away from myself or anyone else while I'm heating it up. Usually takes about 5 or 10 minutes of heating for this tar to get gooey. Okay, I think this one's going to be pretty easy. I can see it bulging out on its own already, so I think just a little twist. Yep, a little more heat. That's just about come out completely on its own, so. There we go, and that's what was holding it in. Big tar blob on the end there. It's a little stinky when they come out, and you can probably see those fumes rising off. But there's nothing really horribly toxic in here or anything. That's really just tar. We'll just let that cool down and tackle this last one. Boy, there was a surprising amount of tar in the smallest cap. Well, set these aside, let them cool. Once they do, I will cut off and discard these insides, then start working on rebuilding them.